things. And so today we'll do 4.1 and 4.2. And really, there is no difference between 4.1 and 4.2. A mathematician will argue me and say, yes, there is a huge difference, but there really isn't. 4.1 is rates and unit rates. And all rates is I'm comparing two quantities that do not have the same units. 4.2 is ratios. Ratios are comparing two things that do have the same units. So mathematically, in my opinion, they are the same. It's the units that are different, right? So that is the only difference between 4.1 and 4.2. The methods, the tricks, the calculations are identical. One, the rates are the same. One, the rates, not rates, the units. One of the units are the same. One of the units are not, right? And so 4.3 and 4.4, I could pretty much finish this whole chapter today if we went fast enough, but I don't want to, is just turning fractions into decimals and then turning decimals into percentages. That is this whole chapter. So if we get 4.1 and 4.2 down, next week when you have to take the test, there's not a lot to 4.3 and 4.4. It's just turning it into some percentage problems, right? So we'll learn a little bit of that. So I would encourage you not to take the test after Tuesday. What I would encourage you to do, though, is take the practice test before Tuesday. Because if you take the practice test before Tuesday, you get to ask me questions on Tuesday. And then I can answer those questions. And then we'll finish chapter 4, and then we'll be done. And then you'll have from Wednesday, because we usually get done Tuesday night, so I doubt you want to sit through class and then take the test, but some of you may. But then you got Wednesday all the way through Sunday to finish it, right? So that would be my plan approach. But again, how you do it is completely up to you. So definitions, and again, just interrupt me if you have questions. So a rate is a fraction used to compare two quantities, and the two quantities do not have the same units. So $12 per hour, right? So I'm comparing money to time. It's a rate. 4 projects, 2 exams. Comparing projects to exams. So if you want to write these as rates, there's multiple ways we can write rates. So I can do $12. Sorry, I'm trying to get my draw working here. There we go. $12 per, which is just a line, I forgot to put the 12 in, that might help. $12 per 1 hour, right? So I can write it as a fraction. I can do $12 over 1 hour. I can write it to the word with 2, which is how it's written over there. And I can write it as a semicolon, $12, not semicolon, sorry, colon, dot, dot, 1 hour. Lots of ways to write it, right? I always default to fraction form because I like math and I don't mind fractions. So I just put everything in fraction form because then once it's in fraction form, I can do calculations. But rate, different conversions, right? So 4 projects to 2 exams. So 4 projects for block 1. In total for the course compared to our 2 exams. And so what we can do by setting it up in this format is we can solve equations. And so say we're solving, we know that 1 inch, and this is where this is the piece that really brings into nursing and dosage calc, right? I know I have 1 inch to 5 miles on a map. And so if I measure out 3 inches on the map, how many miles is that, right? And so you can solve this, I think like Serena said, I can just apply logic here and figure that out, right? But if you set this up as a calculation ratio problem, we can do this thing called cross multiplication. So I take the numerator of the first, and I multiply it by the denominator of the second. So 1 times x is 1x, right? And then I take the denominator of the first and I multiply it by the numerator of the second. So 5 times 3 is 15. And then you can see the x has the word miles on it. So I keep that here and I end up with 15 miles. Now, was it way easier to apply logic to probably solve this problem? Probably. right? But I was just trying to come up with a simple problem so we could see this approach. This approach always works. The problem is it's very algebraically. This one, it worked out really easy, but when X is in another spot, you might have to do an extra step sometimes. So that's where it becomes a little more tricky, is moving things around. And we'll do a few of these so you can kind of see that. But there's lots of ways to solve it. So it's just, again, kind of thinking these things through on how you want to find that missing piece, right? That missing rate. And again, if you set it up this way, whatever unit is on the thing you're looking for, that is the unit that will be on the answer. Questions so far? All right, so I don't know if the price has changed. So I made this problem a while ago, but I think it costs $5 to get a print card here on campus. I know some of you have never been on campus, so you can't confirm or deny that. But once we're back open on campus, I'm knocking on wood that it's by fall. So our print card costs $5, and it allows you to print 100 pages, right? So again, we set up our ratio problem here. I mean, our rate problem, because it's different things. So $5 allows you to do 100 pages. So then you might want to know, well, how much am I paying per page, right? So what does it cost to print one page? So we're looking for cost. So how much does it cost? So I'll put an X there because I'm an algebra guy, to print one page. And again, we do our little cross multiplication trick. 5 times 1 is 5. Then we do 100 times X, which is 100X. And so now this is, if you use this method, this is where algebra comes into play, right? Because now X is not by itself. So how do I get X by itself? Well, I divide by 100 because then they cancel, which moves this 100 over here, right? And then so 5 divided by 100, use our trusty calculator if you don't know it, equals 0.05. 0.05 is X. And again, X is on money, so my symbol is $, so it costs 5 cents if you buy a print card to print a page. Now, again, if you have a method that works for you, use it, because I'm not going to say solve this problem using cross multiplication. I am just going to ask it just like this. A print card costs $5. It allows you to print 100 pages. What does it cost you to print one page, right? So keep going again. This is no questions. Minimum wage is $12 per hour. I think it's actually gone up now, but I'm not 100% sure if it has. 12 per 1 hour. What is my gross pay if I work 10.5 hours? Again, this is very similar to the problem we just did, right? And so once you get comfortable with these, you can start doing tricks here, right? Because X is already here by itself, why would I bother multiplying it by that? Just leave it right where it is, right? So then I can just multiply 12 times 10.5. Again, it's over 1, which is not a big deal. So then 12 times 10.5 is 126. So I made $126 in 10.5 hours of work. Lots of ways to attack these problems. It really doesn't matter. The big takeaway from 4.1 is just that. A rate is a way to compare two quantities that do not have the same units. Questions on rates? All right, unit rate. All a unit rate means is I want to get a denominator of 1, right? And the reason was I'm trying to get to that old saying, I want to compare apples to apples. So by having a denominator of 1, I can compare these two things. So say CMCC bookstore is having a sale on notebooks. You buy one notebook, you get 2 free, right? So if a notebook costs you $3.75, what is the new rate for the notebook that is on sale, right? So I'm doing and this one's a little trickier for setting up the cross multiplication problem. This one you're gonna have to think out logically. So one notebook, so $3.75 for one notebook. I cannot do this little proportion problem because of the word free, right? So now I got to kind of think through a little bit logically here, right? So now I am basically getting $3.75. I'm still paying the same price, but I'm getting 3 notebooks. So 3.75 divided by 3 is now they know they cost $1.25. So that's where rates can get tricky, is when they don't always set up nicely in that proportion problem. And I got to kind of apply, like Serena said, a little bit of logic to it. So because of the sale, I am basically paying $1.25 a notebook. Last question for this section, and I'm going to give you, oh, wrong way, a second to work on it, and then I'll ask for input. So you go to your favorite place to buy coffee, Dunkin', Starbucks, local gas station. What is the other one? Aroma Joe's, McDonald's, wherever you like to get your coffee. So you can buy a 16-ounce cup coffee for $4.50 or a 12-ounce cup for $3.75. Which one is a better deal? Now we can have an argument. The bigger cup because I need more coffee is obviously the better deal, but which one cost-wise is a better deal? All right. So I got 303. I'll come back in about 2 minutes. All right, what we got? Which one's better?
The 16.
The 16? Okay, how'd you do it?
Well, it's just a better deal because you take 450, you divide it by 16, you end up with 0.28125. So basically that's 28 cents.
Okay, yep.
Over one. And you compare that to 375 divided by 12. Okay. And you come up with 31 point or 0.3125 over 1. So it's roughly 31 cents.
Exactly. Perfect. Anyone solve it another way?
Can you show another way to solve it besides that? I mean, I did it the same way.
I would do it the same way too. So
Okay. All right. I just didn't know if there was, okay.
I guess you could set up as a ratio problem. And, so if I set up as a ratio, I get 450. Because remember, ratios, all they are is things that are the same measurement. So 450 over 375. Right, so 450 divided by 3. Well, I'll put it in calculator mode. So let's see, was that 450 over 375? Reduces to 6 over 5, right? Or if I put it in decimal form, 1.2. Because the number is greater than 1, then I know the top number is the better deal. But we already know it's bigger. Oh no, I don't think that would even work because now our sizes are different. So yeah, that won't even work either. I
Okay.
thought it would, but no. I was trying to come up with another way. That's not a good way either. I think that's basically the only way. I just didn't know someone thought of something else. That's how I'd attacked it too. I was thinking my way might have actually been something, but that's not. That's not gonna. This just shows you 450 is bigger than 375, which you already know. But we had to take into account the size. So I think that's the only way I can think of. But sometimes there's more than one way to do it. All right, so moving on to ratios then, which I kind of started, even though I messed up that problem. All ratio is comparing two measurements that have the same type, right? And again, this is where I kind of wrote it out. You can have it in words with the word two. You can put it with a colon, or you can write it as a fraction. And so what an equivalent ratio is basically ratios that are the same when you simplify them down. So 1/2 to 2/4 to 3/6, right? Because 1 over 2, 2 over 4, 3 over 6. These things all equal each other. So if I simplify 2/4, I get 1/2. I simplify 3/6, I also get 1/2. So that is what is called an equivalent ratio. Even though the numbers are different, ratio-wise, they are the same, right? And so when we're doing ratio problems, we're just comparing things that are the same. So these are all marbles. Even though they're different colors, they're all marbles. So find the following ratios: red to blue marbles. So there's 4 red. And I'm going to use the colon on this one just because I can. To 5 blue. That's it. Right? It doesn't simplify down. You could put it over 4/5 if you want, red to blue. But whatever comes first is what goes on top. So red to yellow, that's just 4/3. And then blue to yellow, 5/3. Then you can have a larger number on the top. That is completely fine, right? It's called an improper fraction, but when the
And it doesn't matter if you're using it as a fraction or as a ratio with the colon, doesn't
Nope.
matter. Same
Nope.
thing.
Because we're not doing anything. We're not here in a minute. We'll do something where we compare it, right? But for now, it's just realizing we're just comparing things that are the same. So I think I have what two examples. Yeah, one. That's the answer to that one. So, yeah, we're way ahead here. Maybe we'll just bring up some. Maybe I'll do a little bit of 4.3. That'll give us a little more review time next week. So a trail mix recipe contains M&Ms, Chex Mix, and peanuts, right? So the ratio is 1 ounce of M&Ms to 4 ounces of Chex Mix to 2 ounces of peanuts, right? So I go to the store and I decide, well, I'm going to buy a 12-ounce box of Chex Mix, and I don't want to have any leftovers. So how many ounces of M&Ms and how many ounces of peanuts do I need if I want to keep the ratio the same as the recipe says, right? So all my culinary students in the class, they should be really good at these type of problems. So I got 12 ounce. So my ratio is I do these in pieces. So first I'll compare Chex Mix to my M&Ms, right? So I know my ratio is 4:1. And now I have 12 ounces of Chex Mix. So how many ounces of M&Ms do I need, right? So I'll just call this M for M&Ms. So do my cross multiplication thing, all right? So I get 4M to 12, and then divide both sides by 4. I get M is 3. So I need 3 ounces of M&Ms for my 12-ounce box of Chex Mix.
Just a
And-
quick question.
Yep.
Why did you put Chex Mix on top when M&Ms came first?
You could have done that. So I guess just because I just put the 2 there, but it doesn't matter when we're in ratios because the units are the same. So now say I did it the other way. So you want M&Ms on top. So 1 to 4 over M to 12, right? So then I still get the same when I cross multiply it back to the 4M12. So that's the kind of cool thing with, because we're just looking for the same measurement. So we know it's going to be ounces. You will get the same answer.
Okay.
Yep.
'Cause I wrote down what comes first is on
Yeah.
top, and then you did it the other way, and I was like,
Yeah.
oh, wait a minute, I missed something.
Nope, I was correct. That's what we did up here. When when you're comparing those and you're writing them out, that's how it should have. So you're correct. I should have stuck to that methodology, but mathematically it does.
No,
work out.
that's okay. I just wanted to make sure I got it.
No, that's perfect. That's a great question. Yeah, and so I see Tanner's already solved the peanut one, but the same thing with the peanuts, right? So I have this one I'll do on top. So we have what's peanuts? 2 ounces of peanuts to 4 ounces of Chex gives me my peanuts to my 12. And now because P is on top, this makes it a little bit easier. I can just leave it where it is, multiply the 12 over here. So 12 times 2 is 24, divided by 4 is 6. And like Tanner posted, I need 6 ounces of peanuts. So I go to the grocery store, I buy a box of 12-ounce box of Chex Mix, then I go get 3 ounces of M&Ms and then 6 ounces of peanuts. And this is a very simple recipe. I know if you make trail mix, there's way more cool stuff that goes into it, but we can be here all day making different ratios for a trail mix, depending on people's preferences. So maple. So one thing I done since I've retired from the Army and moved back to Maine here. Last year was the first year I tried to do it by myself. Was make my own maple syrup. So if you've ever done it before, the ratio is 40:1. So you need approximately, it's a rough estimate, 40 gallons of maple sap to make 1 gallon of syrup, right? That's the rough estimate. And anyone that's done this for a while will argue me, well, it depends on the sugar content. Yes, I know, but we're a beginner math class, so we'll be beginner maple syrupers as well. All right, so we'll follow the ratio of 40:1. So I want to be able to give some away at the end of the season. So I want to make 8 quarts and 24 pints of maple syrup to give away in the spring. How much sap do I need to collect? So again, I'll give a few minutes to see if we can work through this problem. And then I'll check in with everyone. And this was a tough one because I've got different conversions. So this is very much a teas problem. Probably won't be a maple syrup question on the teas, but they're comparing different container sizes. And if you don't remember, I think it's what, 4 quarts in a gallon and then 2 pints in a quart. Right, so I'll put that in there just for conversion purposes. Is what, if I remember correctly, hopefully I'm correct, 4 quarts equal 1 gallon GL. And then 2 pints equals 1 quart, if I remember off the top of my head correctly. How are we doing? All right, got some answers in here. I think that is correct. I erased the answers, so I don't even remember. But I'm gonna go with it since two of you agreed. So I'm gonna show you instead of having you explain. I want to show this because this is how I attack these problems, and there's more than one way. Because words aren't my friend, as some of you were talking about at the beginning of class. I want to get rid of the words, and if I get rid of the words, then I know my numbers will fall in the right place, right? And this is how I kind of tutor dosage calc. So I know I want to end at 8 quarts, right? And so, no, yeah, so sorry, I don't want to end there. I want to start there because I know I'm going to have 8 quarts at the end. That's what I meant to say. So I'm going to start with 8 quarts because that's what I want to have to give away, right? But I want sap is measured in gallons. So to get from there to there, I'm going to get my words to cancel. So if I have quarts on the top here, then I know I have to put a quarts here on the bottom. And then I go to my conversions. If that's 4 quarts to 1 gallon, and now my gallon is on the top where my answer is supposed to be. So all my conversions are correct because then words can cancel. This quart cancels that quart, and I am left with just the word gallon. All my other words are gone. So I know all my numbers are in the right place, right? So now I end up getting 8. And the 4 is on the bottom, so that becomes 8 divided by 4. So I need 2 gallons of syrup, right? To fill my 8 quarts. And now to do my pints, I know, again, I want to finish with the 24 pints. So I put it over 1 just as a placeholder. I need to cancel my pint. So I put pint here on the bottom. Those two cancel. So there's a 2 pint for 1 quart. Well, I'm not at the gallon where I want to be yet, right? So I have to do another conversion. So I put my quart on the bottom. Here's where my 4 goes. And then I got my 1 gallon on the top. And now my quarts cancel and I got gallon to gallons. So I'm now in the right units. So I can multiply across. 24 times 1 is 24. 2 times 4 is 8. 24 divided by 8 is 3. So add those two together. I need 5 gallons of syrup if I want to meet my quota. And now I do the ratio, it's 40 to 1. So I take the 5 times 40. And just like everyone posted in chat, I need 200 gallons of sap.
So that's not even close to how I did it because I like words and that was painful to me to watch you do that. It's like watching my kids do Common Core math. No, seriously though. So all I did was just said, okay, 8 quarts. So there's my 2 gallons, 24, there's 3, there's my 5, 40 over 1 is equal to X over 5 times the, and then I just double checked.
Perfect.
Wow.
Yep. There's lots of ways to do it. Right.
Okay.
So for people that have not done these well, and that's where they don't know where to put the numbers, this is a trick for that. And this is how I know how to teach like chemistry and biology to do it as well. But it's not required. And again, I'm never gonna make you do it this way. And so if you have a method like, hey, I can get these things to move right where I need them to do, perfect. Go right for it. I don't show those tricks because when people that just don't have an understanding at all, they just don't know where the numbers come from, they get really confused. But yes, I would not have done it this way for this problem either, but I like to show the whole word cancellation trick. But
Okay.
no, that's perfect. Yeah. If you got 200 gallons and your method works. So let's see, where you have like 40 minutes left. And I'll let us decide what we want to do. I can move on and do a little bit of 4.3, which would give us a little more time next week for test stuff, or we can just stop here because that's where syllabus says to go, and we can talk practice problems or call early. What are we feeling?
I've got to head out of here and go to public speaking. So if you guys continue on, I'll just watch it later
Okay.
on. So. I'll see you guys later.
All right, Serena. Anyone else have any? All right, so I got to keep going. All right, I got a couple head nods. All right, so I'm going a little bit into 4.3 then. And then we'll do 4.4 next week, which is not a lot, and then they'll give us plenty of time to kind of do stuff for the test, and then there won't be as much new material next week. And there's not a lot to 4.3. This chapter there's not a lot to, because I think most of you have done this before. You've either done it in some other math class and you just didn't realize it because they maybe not have used the same terms, right? But 4.1 and 4.2 is just fractions, right? And it's just moving things around to solve the cross multiplication tricks. 4.3 is proportions and percentages. Proportions and percentages are the exact same thing, right? Again, it can be written as a fraction, it can be written as a decimal, or it can be written as a percent with a percent sign. So way percentages work, if I take a number and I multiply it by 100, that adds the percent symbol. If I take a number with a percent symbol and I divide by 100, that removes the percent symbol. That is the same trick as moving decimals 2 places to the right or 2 places to the left, right? The reason you're allowed to move the decimal 2 places to the right or 2 places to the left is the whole multiplier divide by 100, right? So that is the math reason why you can do it. So for an example, 1/2 times 100 gives me 50%. Or if I take 50% and I divide it by 100, I get 0.5, which is 1/2. So knowing how to move and add and remove the decimal is key. So when you're doing the homeworks or the test, be careful. If the percent symbol is in the answer, make sure that you put in the that. If it asks for it as a percent answer, put in the percent symbol. If it asks for it any other way, then it should take it as a fraction or a decimal. All right, so just read, because nothing's going to frustrate you more when you put in 1/2 and it says it's wrong because it has a percent symbol. 1/2% is very different than 50%, right? So we got to make sure that we put the conversions in correctly. And then so part of this is just a wordplay. So the word of means to multiply. And the word is means equals. So if I just write out in a math equation exactly what the problem is telling me to do, then I can solve this. 60% of means to multiply. 340 equals what? Right? So just take the words and knowing that of means multiplying, is means equals. So now I go to my calculator. So if your calculator has a percent symbol, then there's nothing you have to do. But if it doesn't have a percent symbol, I have to turn this into something I can put in my calculator. So again, if I divide by 100, I get 0.6, and I do 0.6 times 340. And I get 204. And so again, do you have to solve it this way? No, right? But if you understand what the words are telling you, then it makes it a little bit better. Right. And so if you haven't noticed to now, right, I haven't thrown out the horrible words yet because it gives students huge anxiety. Almost every single problem we have done since chapter 1 has been a word problem. So that means the entire test is word problems. You've been doing them the entire semester, so don't panic on me now, right? If you've been doing the homeworks, you've been doing word problems the whole time. So we're okay. But everything has been word problems up to this point, right? It's negate this statement, write this statement, create a truth table off these statements. 60% of 340 is what number? All a word problem means is this word's in the problem, right? So don't panic. We've been doing them the whole semester so far. 34 is 20% of what? Right? So now you have to do some algebra. So if you don't like question mark, put an X there, right? And so now if I do this algebraically, I get 34 equals 0.2x. And then I divide both sides by 0.2. So 34 divided by 0.2. And I get 170. And this one is 204. That's supposed to be a 7. Yeah, making it worse by trying to clean it up. Erase. 1, 7, 0. And that's really all there is. There is to percentages. It's just moving things around to kind of get to them. So I have two little examples here, right? So Massachusetts, so this goes to the whole, I like to use real life things in my class because we can see how this actually is outside the classroom, because the biggest thing I get when I teach algebra is, when will I ever use this? I only have to take this class because someone told me I had to, right? So I like to take real problems. So this is a wonderful problem about our Central Maine Clean Energy Act, or CMP corridor, if you've been following this for a few years. So I went and actually collected some data to see where the truth lies, right? Because you can't trust the commercials because they're trying to get you to buy something or buy into something. But if you go collect data and you understand how to do calculations, what we're learning in this class, you can figure out where the truth really lies. So Massachusetts is currently using, it gets 70% of its energy from natural gas. So Massachusetts wants to get off natural gas. Hydro-Quebec, who is going to supply the hydropower to Massachusetts through the CMP corridor, exports 17% of its total electricity it makes. So the dam creates electricity, and 17% of the electricity they make, they export, which means send out to other countries, right? But it only counts for 27% of their income. So this is where, if you're reading about the corridor, you can see how percentages are used in current affairs. Now, where does calculations come into place is how does it affect Maine? So currently, Maine has 17.6 million acres of forest. And one unique fact about our state is 89.1% of our state is forest. Right. So if you look at the state of Maine, almost 90% of our population live along the coastline, right? And if you go up into northern Maine where they're trying to put this, lots of trees. And so depending on what side of the fence you stand on here, people that are opposing it are people that live up there because they like lots of their trees, right? Because there are a lot of outdoors activities. Others are saying that it's not going to have that big of effect on it. So again, those are people's opinions. So if we take the math, how much of the forest is actually going to get cut? So according to the Clean Energy Corridor, they're only going to cut this much. Again, how much is actually going to get cut, we won't know until actually they cut. So what they're saying is they are only going to cut 0.001% to put in the new lines. So how do we solve this? So if we take the 117.6 million acres of land that is forest, and they're going to cut 1% of that, that means we're going to multiply this by 0.001%, right? And so just to make sure I don't mess up my conversion here, I am actually going to do the divide by 100 trick in my calculator, because that makes sure everything does get moved properly. So now I just go to my calculator and type 17.6 times 0.001 divided by 100. And I get 0.000176. And what makes this hard is the word million. So if you really want to see it, then we got to move this 17.6 million, right, is the same as writing 17,600,000. Make sure I got the right amount of zeros in here. There we go. So I've moved the decimal 1, 2, 3, 4, 5, 6 places. So move the decimal 1, 2, 3, 4, 5, 6 places. So I'm actually only cutting 176 acres of the forest. Now we're back to, again, opinion. Is 176 acres a lot? Again, that probably depends who you're asking. If it's in your backyard, maybe. If it's not in your backyard, probably not. So there's where the big discrepancy of why the state's arguing about it. Because people that aren't living up there are saying 176 acres is not a lot of land. If this is an area that you use 176 acres, maybe a lot of it. And I'm not trying to convince you what side. I'm trying to show you how math can help solve real life problems if we separate our biases and we actually look at the numbers and do some calculations, right? Now we are comparing things. So now we can argue, is 176 acres a lot? Because why I would argue that this is misleading is when you tell someone that doesn't understand math that we're cutting 0.001%, they're like, that's nothing. Well, it is actually something. It's 176 acres. Now we can talk about, is 176 acres a lot or not, right? And so that's where understanding how percentages work, you can take numbers that are so large that it's hard for our mind to wrap around and turn it into something that we can relate to. And then I have another problem about the Senate race. We'll kind of stop there. So next week, we'll get into using percentages, which is basically what we've been doing already, just a couple word problems. And then we talk about this new thing on absolute change versus percent change. We'll do that kind of a problem, which will probably take about.
Just most of us have done this all the time. So I try to pick something that we've all seen, right? So you and your some friends went out to dinner and your check was $75.87. You have a coupon for 15% off. So what is the new price of your check, right? So what we do here is we take the $75.87 and we are going to take 15% off. So times this by 0.15. So we go to our calculator. So 75.87 times 0.15 gives us $11.38. So that's how much is deducted from our check. So then I just have to subtract those two numbers, 75.87 minus my answer. So my check is now reduced to 64.49. Right? Because I just took this and I subtracted that. All right. So now that they've taken off the coupon, now we got to pay our lovely sales tax, right? So now we're going to add back on 8% of that. So again, we do the same thing. We take our new price of 60. Oops, I don't know if I put the decimal there for. So erase that so I don't confuse people when I go back and look at my notes. I take the old price, the new price, sorry, not old, 64.49. I multiply that by the sales tax, so 0.08. Again, make sure you're comfortable moving either the decimal around. If you're not, to get rid of the percent symbol, if I divide this by 100, it will put it into the proper decimal form that I need. Right? So now I multiply these numbers, so 64.49, and I multiply, oops, I hit divide on my calculator. Multiply that by 0.08. And so now I got to pay $5 and, I don't want to put a decimal goes there, $5.1592, so $5.16 in tax. So then I add that back on, plus 64.49. And so my final check price is 69.6492 or 69.65. Well, dollar signs in here. So how much do you typically tip, right? So depending on how good your service was, my wife and most of my girls all worked in the food industry for some time of their life. So I tip well because I know how much they don't make usually. So I usually tip 20%. A lot of the times on your coupon receipts now, they do some of the calculations for you, right? So say it was good service, so we're going to tip 20%. So then again, we've just been doing what we do. We multiply this number by 20% to figure out how much we tip. So multiply that by 0.2, and we get $13 and 9298, so $13.92, 93 cents, sorry, rounding up. And again, finally, I add these together. So how much do you tip? 20%. That's what I did here. And then it gives me a tip price of that. So you add these together. And it's $83.58. So now everybody has their own ways. I don't sit here and do all this math, right? I do like the estimate kind of problems that we learned back in chapter 1, right? I look at my receipt when they bring it to me and I see it's $69.65. So I tell myself, yeah, that's about $70. 20%. So if you take 10% of that 20% means double it. So I'm going to give them a $14 tip. So 70, so I just write $84 on the bottom, and then they figure out what they do. How you do this in the real world is up to you. But there's lots of ways to kind of estimate, which is what I did here in green, or you can actually do the full calculations out. If you prefer in person. Anyone do anything when they do these kind of things for quick math? None, no one wants to share. But we do percentages all the time, right? And so, go to stores. Kohl's is notorious for always sending coupons, right? And, you do the little scratch ticket to see if you get the 15, 20, or 30% off. And then you have your Kohl's cash, and, all these people give you rewards and do all these things to kind of try to get you in to buy things and stuff. Perfect. So you can see that's why I like this class a lot, because this is stuff that we do all the time. So we don't think about it, but we use percentages a lot in our lives. And so where we get a little tricky here is this absolute change versus percent change. I think this is an area that I wish more people understood, and not so much the calculations, but what it tells us, right? Because I think it's very misleading when you don't understand this, and especially like during this time of COVID, and they tell you death rates are increased by 500%, right? And so they're like, holy cow, what is that? That's a huge number. What does that mean? And they don't explain that. You just know it went up by 500%. And so where they're getting those numbers from, it's not like up top here. They didn't take the number of deaths and multiply it by 5, right? Because that's what 500% means up here. That's because what we were doing, right? We 15% off, we multiply it by 0.15. Sales tax, we multiplied by 0.8 and added. 20% multiplied by 0.2 and added. When they're talking about change, that is a different animal than what we do up here. So it's not like 500% and we're multiplying by all these numbers. So the way you find out how much percent change something is, you calculate absolute change, which is you take whatever the new amount is and you subtract the original amount, and then you take the absolute value, because a positive absolute change just means it increased. A negative absolute change just means it decreased, but the amount that it changed is the same. It just either went up or down. So that's why we take the absolute value of it. We take the absolute value. So, and then we just have to pay attention if it was negative or positive. So we can say this was a percent increase or this was a percent decrease, right? So percent change then is we take our previous answer of absolute change and we divide it by the original amount and multiply by 100, right? And the reason we multiply it by 100 is to bring in our friend, the percent symbol, right? So a quick, easy number we can relate to. So say our first day of class, 22 students were present for class. And this typically happens because there's always one or two that forget the semester. Oh, excuse me, the semester has started. And then by the second day of class, everyone shows up. because they're like, oh, the semester started, I got to show up. So the second day of class, 25 students show up. And then by the third day of class, students have made their decision in the first week if they're staying in the class or not, and they drop, so they get all their money back. So the third day of class, only 20 students showed up, right? So I, as an instructor, want to know how much was my percent of change. So in part A, find the percent change between the first day of class and the second day of class. So our first day of class is our original amount. Second day of class is our new amount. So absolute value of new, which is 25 students. And I subtract out my original, which was 22. So 25 minus 22 is 3. And it's already positive, but the absolute value of, these are absolute values, because so everyone looks back at my notes, I don't think that's 131. Absolute value of 3 is still 3. So there's my absolute change. And then I divide that by my original amount, which is 22. So 3 divided by 22 equals 0.1364. Multiply that by 100, and I get a 13.64% change. And because more students showed up on the second day, I don't know, I wrote 36. Can't write down what I said. On the second day of class, I had a 13.64% increase in their amount of attendance in my classroom. Part B, find the percent change between the second day of class and the third day of class, right? So now, see how many people dropped out of my class. So I take my new amount of 20 students on the third day. I subtract out the original amount, which was the second day. So 20 minus 25 is a -5. So I know it is a decrease, but again, I take the absolute value, so that becomes a 5. And I divide that by the original amount, which is 25 in this case. And then again, I multiply that by 100, and I get 20%. So I had a 20% decrease, because original value was negative before I took the absolute value. So I have a 20% decrease in the amount of students between day 2 and day 3. So that's how we use percent change. And the key is just making sure you get the numbers in the right place, what the original amount is, and then always make it positive, divide by the original amount, and multiply by 100. So what I have here for a few minutes, what I would like us to do is, I haven't Googled if it's come out yet. I think it has, but I haven't checked recently. So I still got the old data of 18 and 19. 19 and 20 should be out by now. But last time I checked, it wasn't. So I don't know if it's just late because of COVID. But here was the total head counts between the community colleges in Maine. And so in September 23, 2000, in September 23rd and 2018, this is how many students were enrolled at these colleges. September 23rd of 2019, so a year later, this is how many students were enrolled in the college. And so what I would like you to do for a minute or two is pick 3, but just pick one. Pick a college that you want to compare. Well, pick two, because I want you to compare between somebody, and figure out their percent change, right? Because it's hard to see, because you can see like Southern Maine has the most students, right? So they went up. CM also went up, right? And so they have more students. So it's hard to compare who's doing better between CM and SM if we're just looking at enrollment. They have more students. So is it really that big of, did they do better than us? And the easiest way to see if they did better than us is to do percent change, right? And you don't have to do those 2 schools, right? But I have all of them listed here, so you can pick 2 and just figure out, who did better using percent change. So I have 307. I'll be back in, I'll give you 5 minutes. So 312. it might not, shouldn't take that long, but I'll give everybody 312. See if we pick 2 schools, and then we'll do one together when we come back. I'll still be here for people who have questions, but I'm gonna let you work through it. So if someone does some of these on their own later, they can see some answers that their classmates got. Right, so quite a few in here. And I'll do one that way, so for the ones that didn't do one, and I don't understand where everybody's getting the answers and they're too nervous to ask, which I wish we wouldn't be, but that's all right. So I'll do CM since that's where we go. Chris has already did SM, so let's see if we beat out SM. They always seem to be our competition. So our original, so our new is 3,024. And we subtract out our new, sorry, we subtract out our original, 2873. So go to my calculator, 3024 divided, no, minus, I'm getting ahead of myself here, subtract 2873. And I get 151. And then I divide it by the original amount. So I divide that by 2873. So 151 divided by the original amount. And I get 0.053. So Central Maine went up 5.3%. So you can see other schools definitely did a little bit better than we did. So good work. So that finishes out chapter 4 in percentages. And we did the house problem at the beginning, which is also a percentage problem. So any questions on anything as we finish out our first block? Right on schedule too. All right, I'll be checking Hawks every day to update people's. Yeah, I'll look for the numbers and see if I can put that in chapter 4 activity. I'll try to find it by next week, and if I can find it, I'll throw it in the chapter 4 activity to see if the numbers have been published yet. I hadn't seen them last time I checked, but I haven't checked for a while either. I know our school keeps reporting that our numbers haven't dropped too badly. It'll be interesting to see what our official numbers reported to the state, because that's where I got these from, was from a state website. So I'll look and see if I can add those for our little activity after for next week, because I'm interested to see as well. Because they keep telling us the numbers aren't too bad, but it'd be interesting to really see. Any questions on material test? Can we do another of the house problem? Sure. I'll just make up numbers unless you want me to bring up another one. Yeah, so here's all kinds. Here's the activity I had posted before. I don't think I put a house one in here. This is a lot of medical, because there's a lot of you on prescriptions and stuff. So I just want to go to the bottom. So, and it doesn't even have to be house. I'll come up with one that's just like a house problem. So let's see, insert, home, escape, type. So say we go to the store, right? And you see an item. So we're going to buy, I don't know, we'll say we're going to go buy a new refrigerator, and the new refrigerator is on sale for $980, right? So the new refrigerator is on sale for $980, and this is 25% off the original price. What was the original price? Price of the refrigerator. Should have picked something. I spelled that correctly. We'll go with it. All right, so this is very similar to the house problem, right? Because this, you end with 980 and it's 25% off. So what is the original price? And I'll go through the long process, but as you get comfortable with these, you can figure out the short process, right? So again, sale or profit, right? I'm trying to, it's writing really weird all of a sudden. Why do I have a delay? Sale equals original minus, we'll call it reduction here. No, so you probably, so what you probably did is you probably took 25% off. This is how much it is for sale, and they're already saying they've already taken the sale price off.
I did. Well, I did because yeah, I took the 25% off and then I subtracted that what the 25% would be. Okay.
Yeah.
See, this is why I thank you, Kim, for having him do this because yeah.
Yeah, so you gotta be careful of the wording. So they've already taken the 20% off. So this is what you're gonna pay at the register. Right? And they're trying to get you to buy it by saying,
So I need to add the 20 instead of subtract.
if you do that, it still won't give you the right answer because it's gonna be like the housing problem again. We gotta base it on this concept. So we know we got 25% off. So this is 0.25 right here. Right? Of the original price, which we'll call X again. In the original price, you paid full price, which is just X. And again, if you want to think about it, you put a 1 in front of it for you're paying 100% of the original price. So you subtract these two things and you get 0.75X. And again, the sale price hasn't changed. That's $980. I really don't know what's wrong with my thing. It's like a good half a second behind me. And so what I will do here is if I divide both sides by 0.75, I will figure out the refrigerator originally costs get the right things on my calculator will help as well. $1,006.67. So that's the original price. So if you add your two together, you get close, but you actually end up having it higher because 980 plus 653 is what, well, 1,400 something. So it's a little higher.
I was gonna say, yeah, because I came up with that it was $326.66 difference, the 25% off. So even if I'd added those, I would have come over 1,200. So yeah.
Yep. So this is one where it's now if it was up like the original problems where it's just take your total multiply, right? That's when they'll ask. So if they ask, the question would be, a refrigerator costs $980. You have a 25% off coupon. Then, Serena, your answer is correct.
Well, I was gonna say no. I had $1,306.66 if I added instead of subtracted, which is isn't that what you have? Is 1306.60?
Yeah, if you take 980 and you add,
Because what I did was 25 over 75 is X over 980.
oh, okay, you did as a proportion problem. Okay, yeah.
Yeah, because I don't do algebra. Algebra is not my friend.
So what you said you did what? Let me try your
I went 25, so like 0.25 over 0.75, so like 25% over 75%
Okay.
equals X over 980.
Point equals X over 980. Okay.
So, times 980. 980 times the 25 divided by 75. And that's how I came up with the $326 and change. So I just subtracted it off instead of added it was all I did. Wrong.
Oh, yeah. Okay, yeah, perfect. Yep. Yep, that way works. Good job. So if you wanted to do a proportion, let's see if I could figure. So if we do 0.25, then let's see if we can set up proportion if it makes sense as well. Over 100 equals. No, I don't think this will work because I don't think I have my things in the right place. 980 over X. No. I was trying to think if there's a way you can just get to the final answer without having to do the add subtract, but that's not working. I had to think for that one for a minute. But yeah, if you just added, you would have got it. Yep. So my wife is really quick at these tricks. So the way she looks at it is if I had 25, if it's 25% off, then that means I'm paying 75% of the original price. So she just would take the 980 divided by 0.75 right off. It's like they pay that 25%, I pay 75%. And then she just divided the two. I was tutoring once and I was going through the whole algebraic way, and then she told me afterwards, like, why'd you make that problem so hard? And I'm like, how would you do it? And she told me, I was like, I would never thought of it that way. So lots of ways to solve this problem. Just got to be careful with the words, right? You know, for this one where you already know the reduced price and they're asking you to get back to the beginning versus what we did earlier, where we knew the original price and we're trying to get to the new price. That one's a little bit more straightforward, of going through and just checking those, not checking, but just keep adding and subtracting, reducing and increasing depending on how we're going. One